Today we will discuss about the alicyclic compound or carboxylic compound. The carboxylic or homocyclic compound having the closed chain or the rings of the carbon atoms and bearing certain resemblance with aliphatic compound and its properties known as alicyclic compound. These compound may be simple saturated or unsaturated hydrocarbon or the compound having different functional group like the alcohol, aldehydes and ketone etc. That is the alicyclic compound by cyclic structure. In other words, we can say that the alicyclic compound are the compound which have similar properties with aliphatic compound but differ by cyclic nature. All the alicyclic compound have the general characteristic formula of its parent hydrocarbon, that is CnH2n. This is the general formula. CnH2n is the general formula of aliphatic compounds. The alicyclic compounds are mostly composed of methylene group, hence also known as polymethylene compounds. Now comes on the general methods of preparation of aliphatic compounds. Cyclopentane and cyclohexane may be obtained by the fractional distillation of petroleum. There are following general methods which are applied for the formation of cycloalkane and their derivatives. First one is Freunds method. The dibromoalkane having the terminal halogen atom when treated with zinc and sodium in presence of catalysts like sodium iodide and sodium carbonate forms cycloalkane, and the reaction will be this is 1,4-dibromobutane. When it's react with zinc in presence of sodium iodide and sodium bicarbonate, then these two bromine and these one zinc reacts and the formation of the cyclobutane. This is cyclobutane and ZnBr2 will come out. If react with zinc in presence of sodium iodide and sodium bicarbonate, then these two bromine and one zinc will come out and the formation of the cyclohexane. This is cyclohexane and zinc and two bromine molecule will be come up. Now next method is Perkin method. When malonic ester treated with sodium ethoxide forms disodium malonic ester, which on treatment with alkyl dihalide forms alicyclic carboxylic ester, and on hydrolysis and decarboxylation forms cycloalkane, and the reaction will be COC2H5, COC2H5 CS2 reacts with C2H5O and A, then C2H5OH will come out, sodium will attach this carbon, these two molecules, then either C2H5 here When it again react with CS2Br, CS2Br, then sodium and bromine, all two molecules will come out and the intermediate product will be CS2, CS2C, CO, C2H5, COO, C2H5. Then on hydrolysis, then here will be H and here will be OH, same here H and here OH, then two molecules of C2H5OH will come out and the next intermediate product will be here these two molecules of CO2 will come out. This process is known as decarboxylation. And the final product will be CS2, CS2 and CS2, cycloalkane. This is the method, Perkin method, for the formation of cycloalkane. Next method is Miscellaneous method. When calcium or barium salt of dicarboxylic acid are subjected to dry distillation, a cycloketone having one carbon atom less is formed. Such cycloketones on reduction form cycloalkanes, and the reaction will be, this is the calcium salt, CS2, 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 dicarboxylic, then here is dicarboxylic group attached with calcium. This will come out minus CaCO3, calcium carbonate, and the formation of CS2, CS2, C double bond O. Here this oxygen also. Now when zinc, mercury and acid, that is hydrochloric acid, then CS2, 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 CS2. This is cyclohexane. Cyclohexane is formed in this method. Next method is Dieckmann's method. In Dieckmann's method, esters of dicarboxylic acid undergo the intermolecular condensation in presence of sodium alkoxide to form cyclic ketones, which on Dieckmann reduction forms cycloalkane, and the reaction will be CS2, CS2, C double bond O, single bond O, C2H5 is CS2, CH single H, COO, C2H5. Now this will come out, it is C2H5OH and then forms CS2, 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 CH single bond CO, C2H5, C double bond O. Now when it undergo hydrolysis, then here is H and here is OH. This is CS2, CS2, CS2CH, single bond C, double bond O, and here is COOH. Now this come out CO2 and then forms CS2, CS2, single bond CS2, C double bond O. When in presence of zinc, mercury and hydrochloric acid, then forms CS2, CS2 and CS2, that is cycloalkane, cyclopentane. Here is 5 carbon, the name is cyclopentane. This is the method of Dieckmann's method. Next is Thorpe-Ziegler method. In this method, when aliphatic dinitrile are treated with base like tertiary metallic alkylamine undergo intermolecular cyclization and results in the formation of alicyclic compounds, and the reaction will be CS2 whole N. Here N is the number of CS2 molecule, plus lithium CH C double bond NH and one bond between of them. When they undergo hydrolysis, then CS2 whole N, CH and BCOOH, and decarboxylation, then CO2 will come out and forms CS2 whole N, when again hydrolysis, then O is here and H2 is here, then forms CS2 whole N, CS2, C double bond O, and again single bond between them. In presence of zinc, mercury and hydrochloric acid, they forms CS2 whole N, CS2, CS2 and this bond, and the name is cycloalkane. This is another method of the preparation of cycloalkane. Now next is by the reduction of cyclic unsaturated hydrocarbons. How we can form? Cyclohexane and its derivative may be prepared by the reduction of benzene and its derivative, and the reaction will be, this is the structure of benzene, reduction will be take place and then forms cyclohexane. This is the cyclohexane. Next method is Diels-Alder reaction. When a diene like 1,3-butadiene treated with dienophile then forms cyclic compounds, and the reaction will be, this is the structure of 1,3-butadiene. Then forms tetrahydrobenzene. This is the structure of tetrahydrobenzene. When it undergo reduction, then forms cyclohexane. This is the structure of cyclohexane. This is Diels-Alder reaction. Next method is addition of carbene to alkene. When dichlorocarbene or dibromocarbene treated with alkene undergo to form alicyclic compound, and the reaction will be CH3 single bond CH double bond CH single bond CH3 plus dichlorocarbene, then forms when it undergo reduction, then forms CH3 CH single bond CH CH3 and CH2, that is alicyclic compound. Now next method is by the condensation of unsaturated compound. When unsaturated compound like cinnamic acid slowly polymerize in presence of light, then forms Thorpe-Ziegler acid and Thorpe-Ziegler acid, and the reaction will be C6H5 single bond CH double bond CH single bond COH is 2 molecules. When reacts, then forms C6H5 CH single bond CH single bond COH. This is Thorpe-Ziegler acid, and one more product will be formed. This is C6H5 CH this is Thorpe-Ziegler acid. Is the 2 molecules of both, then forms Thorpe-Ziegler acid and Thorpe-Ziegler acid. The difference between of the both acid is in this C6H5 is present at this end, and in this C6H5 is present at this end. Now next method is ring expansion. Higher alicyclic compound may be prepared by the action of diazomethane on lower homology when suspension of ring occurs by insertion of a methylene group, and the reaction will be CH2, CH2, single bond C, double bond O, CH2, 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 single bond in the presence of CH2 and 2, then forms CH2, CH2, C, single bond O negative, and CH2 and 2. Then forms this will attach with this, and when in presence of zinc, mercury and hydrochloric acid, then forms CH2, 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 and one more CH2. This is 1, 2, 3, 4, 5, 6, 7 cycloheptane or cycloalkane. These are all methods for the preparation of cycloalkenes.